Okay, my name is Kashif and today we have to perform the second experiment that is about we have to find out the angle of friction of two surfaces. So using that angle of friction we can basically find out the coefficient of friction. So that's a very simple experiment and that also demonstrates the properties of the friction. Okay, this is our apparatus in our lab, that is friction on an inclined steel plate. So this one is a steel plate, stainless steel plate, and on the bottom here there is a marking for the angles actually. So you can see here right now it is at 0 degree. So when this plane is horizontal, you can check it from this spirit level that this one is at 0 actually. Okay, so we have to find out the coefficient of friction between two surfaces. For that purpose, we have actually four materials here. The first one is steel. This one is steel. The second one is brass. The third one is nylon. And the fourth is aluminum. So, to find out the angle of friction, what would we have to do? What we will do? We'll place the block here at one side, and right now, because this block is not trying to move, it is stationary. So there is just the interlocking between the projection of this block and this surface. So there, the minute projections of the cold welds of one surface are just in contact with the other surface. So that's just normal. There exists only normal force between the block and this aluminum plane here. So, but what if I do this? I've just tilted it some about 6 degrees. Now, friction 0 here? No, because now the block is trying to move this way. So, because a component of weight that is parallel to this surface is trying to move this block on this inclined plane, but there is an opposite force here that is trying to move, that is resisting the motion of the block. So now there is a force of friction. So if I increased this angle a little bit, now the component of the weight has increased in this direction, but the block has not just moved yet. So it means, okay, if the component of the weight in this direction is increased, then the force in this direction has also increased. The force of friction has increased as well. So it means the force of friction has a remarkable property to adjust its magnitude, but it cannot go against. It cannot go beyond a certain value. So I would further increased the angle of this block. So right now it is at 13 degree, so it's not moving. Now at this angle the block has moved, so I have to just fix it at this angle, or again do that. Okay, this is the angle at which the block moves. So this one is 14 degree. Right now it's at 14 degree. Okay, it's not. Okay, it's between 14 and 15. So the angle of friction for this stainless steel in the block is 14 degree. So in this column I would write stainless steel versus brass, and in this one I would write 14.5, and I would get the coefficient of friction from this formula, like mu s is equal to tangent phi. Yeah. Okay.